Analyze game plan results. In this tutorial, we are going to analyze game plan results that were obtained from a previous run. Game plan analyzes a protein and a bound or docked ligand to determine points where solvent information may be interesting. The game plan results contain ideas for ligand modifications and points where water is stabilizing or destabilizing the protein-ligand complex. We will use the watercolor video extension to configure the display of the game plan results by highlighting any part of the results in the list window. First, load the game plan results. Once the results are loaded, we need to configure the display. To do this, select Extensions, Watercolor. Next, we are going to take a look at the list window. In the list window, you will note there are three main sections. The top section is an analysis section. The second section is a hypothesis section, and the third section is a stabilizing section. This is how game plan results are organized. First, let us take a look at the analysis section. The analysis section is an analysis of how well the ligand compares to the solvent in the binding site. So if you zoom in, you will note there are green mesh spheres placed around the atoms of the ligand. These green mesh atoms indicate the type of site, and they represent a van der Waals site. The size of the sphere indicates the magnitude of the van der Waals interaction. The protein is included here for context reasons. Next, let us take a look at the next section, the hypothesis section. Select polar attachment hypothesis. The bonds in hot pink represent an idea about how to modify the ligand. You can use the down arrow key to look at the other polar attachment hypothesis results. So when modifying the ligand, the suggestion here is to add a 2-atom hydrogen bond acceptor group that could interact favorably with nearby tyrosine residues. The yellow ball indicates that water makes a strong polar interaction at this site in the apoprotein. And once again, the size of the sphere indicates the magnitude of the polar interaction. Next, let us take a look at the third section, the stabilizing section. If you select the stabilizing item in the list window, you will note there's a small green sphere. Small green spheres represent stabilizing points. And depending on your system, you may also have red spheres, which represent destabilizing points. In addition, again, this depends on your system, you may also have green translucent spheres, which represent nonpolar sites, and purple tops, which represent mismatched sites where the ligand polarity does not match that of the solvent. So based on your analysis results, you may want to modify your ligand to make it more compatible with the Apple Pocket solvent electrostatics. You could add a substituent based on the suggested hypothesis, or displace a destabilizing water, or carefully replace a stabilizing water mimicking the interactions of the water. So go ahead and try a few ideas.